So I hope there is no problem with the concepts which were discussed during the last lecture, and we are having sufficient amount of prerequisite for moving on towards the unit number 3. So what this unit number 3 is? Basically, it is unit number 2 from your syllabus, but we are taking it third. Up till now, we have finished the first two units. In unit number 1, we had a discussion, detailed discussion on set theory. Then we have discussed about logics followed by mathematical induction. In unit number 2, we had a discussion, detailed discussion on permutations, the various types of permutations followed by combination part. In the last lecture, we have also discussed what do you mean by binomial coefficient, how to make use of
Yeah.
binomial theorem. Somebody is talking. Am I audible? Whether my voice is clear? Yes. Okay. Fine. So I was saying in the last lecture we have discussed about binomial coefficients. What are these binomial coefficients? These are simply the coefficients associated with powers of x and y in the expansion. So in order to fine tune the computations, we are making use of binomial theorem, which will be able to give you the binomial coefficient at any power. We have seen the formula. X plus y raised to n is equal to summation r varying from 0 to n. N choose r x to the power n minus r into y raised to r. If we are able to deduce the accurate value of, if we are able to deduce the accurate value of r, it is more than sufficient to get the answer. Okay. I think there will not be any problem in having that discussion. Is it? So shall we start for today's session? Okay. So basically, unit number 3, relations and functions. So what do you mean by relation? Why this unit has been introduced in the syllabus of second year computer, specifically discrete mathematics? Okay. So what a relation is? This relation is some kind of association between two or more objects. Objects can be anything. You could have numbers, you can have alphabets, you can have real living entities in the world, you may have trees, chalks, boards, your mobile phones, anything. If we are trying to relate two or more objects together using some kind of meaning, using some kind of relationship in between them, that will be known as a relation. Now an obvious question would come, why we are learning this? You are having subjects like data structures, object oriented programming, computer graphics, where you are making use of various programming entities. Perhaps you are relating two or more programming entities together to deduce some outcome. Okay. So while relating two or more entities together, you must have a prior knowledge about what do you mean by a relationship, how to establish an association between two or more entities. That is the reason why this part has been introduced here. I am not sure whether you have learned about linked list concept in data structures. If you have learned in singly linked list, you must have observed that we are relating first element with the next element using a pointer, next pointer. If you are learning doubly linked list, there you will observe relating next object with the previous or to its next using two pointers, namely next pointer and the previous pointer. So what it is? It is an application of relation. That is the reason why we are learning relations in the discrete manner. Further to this, if you are using Facebook or Instagram on your mobile phone or anywhere, you observe that you are connected with your friends. This is an example of relationship. You get to, okay, you are getting various friend suggestions or follow suggestions on your Instagram account. How it happens? It is happening because of mutual connections that you do have with your peers, with your friends. So it is a real-time example of relationship. Okay. Further to this, if we are observing railway network roadways in India or worldwide. What these are? These are again examples of relations. How can I justify my statement? If I observe one city as one object, the roadway or the railway track that connects two or more cities together can be assumed as an application of relations. Are you getting my point? I hope you are getting. Okay, if we are observing a path between Baramati to Pune, we are trying to establish a kind of association between Baramati and Pune. So an example of a relationship. So what are the various examples of relations? Let's have example. If I say X is father of Y. Second, let me say X is a brother of Z. Next, let me say X is greater than Y. I have written it, okay, statement in the form of statement and not in the form of symbols deliberately. Okay? There is some purpose why I am writing this. Okay. Virat is friend of, for example, and let's say E. What to say? 11 is smaller than 55. So in each and every example, you could observe that we are trying to establish some kind of association between any two objects. In the first example, you are observing association between X and Y has been done using a relationship, using a wording is a father of. So can I say X is in relationship with Y? Yes, it is possible. And for the same, is a father of. This sort of association is used. Remember that while taking a relation, you should be focused on the order of the objects. I mean to say, if we are saying X is a father of Y, can we say that it is equivalent with Y is a father of X? Whether it is valid? It is not valid. Certainly it is not valid. Why? Okay. It is changing the entire meaning of the statement as such. So in a relation, we are taking two or more entities together in certain finite order, finite sequence. So prerequisites for this unit were set theory and the associated algebra, which I have already covered during our earlier lectures. Now this is the right time to learn what they mean by relations and how to apply them in reality. So this is not possible. Okay, this is not possible. You cannot do so. This is totally wrong. That means what? X must always come on the left hand side of is a father, and Y must always come on the right hand side of is a father. So this one is a relation, and what are the objects involved in this relation? We are having objects involved as X and Y. I think this is making a sense. Okay. Alternatively, I used to take this example several times in the classes. X is a brother of Z. Can I say it in reverse? You cannot. Okay, you cannot, because Z can be sister of X as well. It can happen. So in the case for this, if we are saying X is greater than Y, you cannot apply the same meaning while changing the places of X and Y. If you are saying X is greater than Y, certainly Y is not greater than X. Okay. If I say Virat is a friend of Anushka, definitely for this case, for example D, you could write it in reverse, but that will not be applicable for all the examples in real life. Virat is a friend of Anushka, you could say probably Anushka is a friend of Virat, but instead of this, he is a friend of, if I write, he is husband of Anushka. Can we say in reverse? Anushka will be wife of Virat and not the husband. Likewise, okay. In the similar manner, if we say 11 is smaller than 55, the reverse cannot be said to be true. Moving further, what do you mean by n tuple? Before we start with the theory of relations, we must be aware of what do you mean by n tuple. So what is a tuple? Tuple is an ordered sequence of various objects taken in some fixed order. So if I am taking n different objects together in some order, that sequence will be known as n tuple. You are observing what an n tuple is. We are taking a1, a2 up to a of n. This will be known as n tuple. You can use either angular braces or round brackets to denote relations. Okay. So if there are only two objects involved in my tuple, that particular tuple will be known as pair, that we are observing everywhere. Okay, pairs. So a1, a2. See the sequence again. We have written a1 before a2. That doesn't mean that you can write a2 before a1. Okay. There is a difference. If we are having three objects involved in a tuple, that particular tuple will be known as triple, a1, a2, a3. See what these a1, a2 are. These are mere objects. Those can be anything: a number, alphabet, a real person, a non-living object, or anything as such, a city name or anything. Okay. Quadruple, a tuple which is involving four objects. Pentuple, a tuple involving five different objects. In general, if I am having n different objects, this will be known as n tuple. Getting the things? Am I clear up to this point? Shall we proceed? Whether this is fine? Okay. Moving ahead. What do you mean by Cartesian product? A quick revision of Cartesian product so that you will be able to understand the definition of a binary relation more quickly. What is a Cartesian product? We are taking product of two sets. Let A and B are the two finite sets. Then the Cartesian product of A with B, denoted by the symbol A cross B, is given by a pair. I am saying a pair A comma B, such that A belongs to A and B belongs to B. This we are already discussed. Okay. Now let us see what are the various properties of a Cartesian product. What will be A cross B? Can I say A cross B is equal to B cross A? Whether this is valid? Can we say A cross B equal to B cross A? Whether this is possible? I think certainly this will not be possible. You cannot say A cross B equal to B cross A. Why? We already seen. I cannot say X is a father of Y is equal to Y is a father of X. In Cartesian product, we are taking pairs. One element will be picked from A, one element will be picked from B, but the position A is lying on the left hand side of comma while B is lying on the right hand side of comma. This is important. Okay. What I observe? This Cartesian product is not commutative. Do remember, it is not commutative. How to prove? Take any two sets A and B and try to find the Cartesian product. You will observe that both are having different results. Okay, let us check out whether this is associative. A cross B cross C is equal to, I am discussing the properties. They will ask you examples related with these properties in your examination. Okay. A cross B cross C. Yes, certainly Cartesian product is associative, but it is not commutative. We can write by changing the basis, the LHS will be equal to RHS if you observe. Okay, moving further, A intersection B cross C is equal to what it will be? It will be A intersection B cross A intersection C. You will ask me, sir, how can you prove this? My suggestion is take any three sets A, B, C and try to verify LHS and RHS. You would observe that your LHS and RHS are exactly same. So that follows the proof of any of the properties which I am discussing. If I say A union B cross C, this is equal to, this is very interesting. Okay, unit is itself interesting, but the relations and functions is having a lot many concepts to remember. This is the only drawback of this unit. Around 50 concepts are there, 50 formulas, 50 new theorems you will be studying and applying while solving the examples. So A union B cross C is equal to A union B whole cross A union C. This is also applicable. Okay, you can cross verify. Example property number next. A cross B union C. So you are observing here that Cartesian product is distributed over both intersection as well as union is distributed over Cartesian product, and vice versa. A cross B union A cross F B intersection C is equal to what it will be? It will be A cross B intersection A cross. Everybody, these are the properties that one should not forget while recollecting the relationship. We have seen what we mean by Cartesian product. Then we are observing the properties of Cartesian product. Next property, if A and B are empty sets, then A cross B is equal to what? It is equal to 5. It will be again an empty set. So will be the case for B cross B. If both are empty, then obviously your resulting Cartesian product set will also be empty. Okay. Now I do have a question for you. H. Okay. I have a question for you. If cardinality of A is equal to M and cardinality of B is equal to N, can you tell me quickly what will be the cardinality of A cross B? Can you tell me quickly what is the cardinality of A cross B? If you are following the lecture, you should be able to tell the answer. Okay. So if we have been given, there are two sets A and B, wherein cardinality of A is M, cardinality of B is N. What will be the cardinality of A cross B? That is the question. Are you getting my voice? Can you reply? What will be the cardinality of A cross B? Yes, you have replied. Good. That means you are active. There is a need of checking out whether you are active or not. Okay. That. I have quick examples. Only one example. I will not take much for this Cartesian product because I know that you have learned many things about this during our set theory lectures. Find A Q B cross C cross E. Find cardinality of A square cross C. These are the only three examples. Okay, nothing else. Quickly, you can tell me the answers so that we can proceed with the actual concept of relations. What will be A cube? And how many elements I will have in A cube? Yes, be fast in A cube. If you are able to solve this correctly, there is no need of taking more examples on the Cartesian product. We can simply go for the next concept. Yes, will you tell me what is the answer for A cube? Okay. So how to have A cube? A cube is nothing other than A cross A square. This is further equal to, it is nothing other than A cross A cross. I have already told you that do not find the answers Okay. By simply assuming something, you can write down the things and you can go with the solving for a particular problem. Okay. So if this is the thing, what to do? We are going to write this together. Okay, nothing else. One, two, three. Cross. One, two, three. Cross. One, two, three. So those who are having confusion can look out and others can simply go on solving. So I will take first these two cross products and thereafter I will apply the cross product for third. So what is the answer for this? 1, 2, 1, 2, 1, 1, 1, 2, 1. See how I am taking the cross product. Okay, 1. This first element is paired with all elements from the second set. So 1 is paired with 1, 1 is paired with this 2, 1 is paired with this 3. Comma. Now I will choose the second element from the first set. So it is 2, 1, 2, 2, 2, 3, and so on. Okay, we are not here to solve the entire. That means I am not at least going to solve it entire. So you will have such pairs for the first half, and thereafter you are going to again make pairs of these with 1, 2, 3 individual. So can you tell me what is the cardinality of set A quickly? Set A quickly. What is the cardinality of set A? So in this case, AQ, we are observing that the cardinality of A is 3. So we will have 3 raised to 3 coming out to be 27. So you must have 27 pairs in your AQ. You can cross check later on. Okay. So how many pairs will I have in B cross C cross A? Let me check out for B cross C. I will have how much? It will be Mn. So it is 2 3s are 6, 6 3s are 18. So for B, you should get 18. For A, you should get 27 pairs. And for C, you should have 9 3s are again 27. So this you can take as an exercise and go on solve. Should we proceed? Should we proceed? Yeah. Shall we proceed? Yes, because there is no point in getting this. You can later on try these things easily. Okay, so let us proceed. I am talking about an array relation. Please be careful. We have actually started with our syllabus from this point. An array relation. Okay, let A1, comma A2, comma A3 up to A of n be finite sets. This is given. Okay. A relation R is said to be an array relation if and only if R is subset of A1 cross A2 cross A3 cross up to cross of AN. Are you getting the point? So now, if we are getting some smaller subset out of the entire Cartesian product of n different sets, that particular subset will be known as a relation. Am I clear? What do you mean by an array relation? Let us say we are having n different finite sets numbered from A1 to AN. If we are defining a relation R, this relation R will be said to be an array relation if this R is a subset of A1 cross A2 cross A3 cross up to A of n. Are you ready? Okay. So what would be a void relation now? Can you define void relation or empty relation? Can you define what is this empty relation? As we know, okay, empty set is a subset of every other set. So void relation or empty relation is a relation that is empty, that do not contain any pair as such. Right? So we have first define an array relation which is involving n different sets. Okay, a relation defined on n different sets is called n array relation. A void relation or empty relation is a relation which is empty, which does not contain anything. That is empty relation. Now, moving further, unary relation. What do you mean by unary relation? Relation defined on single set. So here you can broaden this definition: a relation which is empty or defined on zero sets. If we are defining a relation on n sets, that is known as n array relation. If I am defining a relation on empty set on zero sets, that will be known as void relation. Unary relation defined on single set. Whether it is making a sense, you should not be confused. Okay? I know that what is given in the books. That is the reason why I am taking with this much speed. If it is making sense, let us proceed. What would be an example of unary relation? Let A equal to 1, 2, 3 R equal to 1. Whether this is unary relation. First of all, you will check out whether this R is a subset of A. We are defining a relation on single set. Okay, is it? We are defining a relation on single set. We are having set A as 1, 2, 3. I have defined a relation R involving two numbers 1, 2. I will check out whether this 1, 2 is a subset of A. Yes, it is. So relation which is defined on a singleton set is called a unary relation. This is a unary relation. Okay. In general, you would have relations like this. Let us say R1 be a relation which says x less than 15 such that x such that x belongs to natural numbers and x, let me have 2 x. So what kind of relationship this is? If I have to have x belonging to natural numbers, obviously natural numbers will be the set on which relation R1 is defined. And what is the condition for defining R1? Value of x must lie between the interval 2 to 5. So R1 will have elements 3, 4. It is again a unary relation. Am I clear? I hope I am clear. Because we have to solve not many problems based on this in coming days. Okay, make it clear and foremost. So now I expect the answers from your side about binary relation, the core part of unit number 2, relations and functions. What do you mean by binary relation? What is binary relation? Can you tell me? Relation defined on Cartesian product of a binary relation is a relation defined on Cartesian product of two sets. Alternatively, I will say binary relation is a subset of Cartesian product defined on exactly two sets. Am I clear? At least tell yes or no. Please, you can say yes or no. So now, can you tell me what will be an example of binary relation? What could be example of binary relation in terms of this notation? Okay, forget about this notation for a while. In terms of this notation, let us try to define R2 as a binary relation. Okay, can you tell me? Example of binary relation. Binary means there will be two elements, two objects involved in defining a relationship. Observe that in unary we were having only one element involved, but in binary I am going to have two elements, okay, for which we will be defining some kind of association. Right? So if you write like this x comma y such that x is less than y, x is less than y, and x comma y less than 5. Can you tell me what are the components of R2 now? Less than 5. Okay. Less than 5, but we will be considering only positive integers. They remember. Let me write here. And x comma y belongs to natural numbers. So now you will not tell me about the negative numbers or zero either. So what are the elements of R2? Can you tell me? One, two, two, three, three, four. Kima has given the answer. Okay, so we need to satisfy the condition. 1, 2, because 1 is less than 2. Yes. Next, 2, 3. She is saying. Next, she is saying what? 3, 4. Okay. Any other arguments? Do we have only these 3 pairs in our R2, or we will have some more as well? Only these 3? 1, 2, 2, 3, 1, 3, 4. I'm going to have other pairs as well satisfying the given condition. Somebody is saying 1, 3, 1, 4, 2, 4. Obviously, yes. It is only said that x comma y is less than 5, and further to this, x should be less than y. So if I write a pair like this, 1 comma 3, whether it is valid? Yes, it is valid because 1 is less than 3. If I write a pair like this, 1 comma 4, whether this is valid? Yes, it is again valid because 1 is less than 4. If I write a pair like this, what should I write? If I write like this 2 comma 4, is it valid? Yes, it is valid. So have we covered all the pairs now? At least 1, 2, 2, 3, 3, 4, 1, 3, 1, 4, 2. Have we covered all? Yes, Swapnil Farande has given the answer 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3. Yeah. So there will be 6 pairs in your relation R2. Why this relation is known as binary relation? Because it is defined on Cartesian product of 2 sets. You will again ask me, how can you prove this? So let me first define my natural number set according to the given constraint. Given constraints are x, y should be less than 5. So we will have 1, 2, 3, 4, 5. I will again take n because I have to deal with Cartesian product of 2, isn't it? 3, 4. What is the Cartesian product of this? And let me make it like this so that you will be able to understand what is happening. So let us take the Cartesian product of this n cross n. What is n cross n? How many pairs I will have in n cross n? 5 5s are 25 pairs you will have. So what are those pairs? First pair will be 1 comma 1. The next pair will be 1 comma 2. Then the other pair will be 1 comma 3 and so on. This is for 1. Okay, comma, I will have other pair like I will pair up 2 with 1, I will pair up 2 with 2, I will pair up 2 with 3 and so on. In a similar manner, I will have total 25 pairs in n cross n. So let us check out what was the definition of binary relation. A relation defined on Cartesian product of 2 sets. Whether we have said that 2 sets must be different? No. You can define a relation on Cartesian product of single set as well. So we have been given a single set, a set of natural numbers. less than 5, isn't it? So I must have 1, 2, 3, 4 only. So I have declared this. And this is the Cartesian product. And what is the definition of relation? Relation should be a subset of. So we will check out whether R2 is a subset of n cross n. Just observe what is our R2. We have figured out R2 is 1, 2, 2, 3, 3, 4, 1, 3, 1, 4, 2, 4. So these are all members of n cross n. Hence, this one is a binary relation. A relation involving two objects defined on Cartesian product of two sets. Am I clear? Am I clear? Should we proceed? Is it fine? Yes. Okay. Next one. Ternary relation. So what will be ternary relation? Relation defined on Cartesian product of three sets. Again, set could be same or different, doesn't matter. R3. Let's have an example of R3. Let me say R3 is a relation. Remember that we will be representing relations using curly brackets. Okay, capital letters will be used for denoting relation. More generally, you should use R, S, T, U likewise for denoting relations. R3 will have X, Y, Z such that X plus Y less than Z. And X, Y, Z belongs to N. Can you tell me few pairs, so few triples of this relation are X plus Y should be less than Z? Can you tell me? If you are clear with the definitions, whatever I am discussing, can you tell me?
What we are learning
Can you tell me? I have given you a representation which is set theoretic. These conditions once met, you would be able to find the components of R3. So what are the elements of R3? X plus Y is less than Z. Three members are involved. So this is ternary. Nobody is able to reply? Okay, can I take 1, 1, 1? Whether this is allowed in R3, 1, 1, 1? We cannot have 1, 1, 1, isn't it? Because 1, 1, 1 is not feasible because it is not satisfying the condition. Condition is first two sum should be less than third one. So can I have 1, comma 1, comma 3? Whether this is valid 1, comma 1, comma 3? I know that you have given the answers and your answers are correct. Those who have given. Okay. Now I am asking whether 1, comma 1, comma 3 is valid. Yes, it is valid because 1 plus 1, 2 is less than 3. In the similar manner, if somebody is saying 1, 2, 4, yes, it is also valid. In the similar manner, if you are saying 2, 2, 6, it is also valid. If somebody is saying 2, 1, 4, it is also valid, and so on. So if I am having three elements involved in establishing some kind of a relationship, this will be known as a ternary relation. Do remember, if I try to write R3 like this by changing out the positions. Okay, for example, I am writing like this 3, 1, 1. As the order is important, how you are writing. Okay, if you write this 1, 1, 3 like 3, 1, 1, it violates a given condition of relation. Okay. So you cannot interchange the positions on your own. It is just like saying being a father of X. Okay, if X is saying X is a father of Y, you are able to say Y is a father of X, and which is totally wrong. So you cannot say like this. Okay. In general, you could reach out to the n-ary relation depending on how many sets are involved in the Cartesian product. Do remember that our relation will be a minor subset, okay, of this entire Cartesian product depending on the criteria which is being satisfied. Okay. Now I have again a question for you. Let cardinality of A is equal to m. I'm talking about now binary relations. So cardinality of B is equal to n. Can you tell me how many relations are possible on? I must be specific. I should write number of binary relations possible on A cross. I will be giving you 2 minutes of time for thinking on it. I want answers from your side. Otherwise, I can give you answer. But if you give, it will be more comfortable. How many binary relations are possible on A cross B? Maximum. If you are getting the question, you should be able to answer as well. The famous question of Pune University exams. Every time they will change these cardinality values. Sometimes they will write cardinality of A is P, cardinality of B is Q, and like this. How many binary relations are possible on Cartesian product of A and B? Two raised to mn. Correct. Very good. Very good. It is 2 raised to mn. How you have got the answer? Can you explain? By unmuting your mic. Why the answer is 2 raised to mn? Why it is not only something else other than 2 raised to mn? Answer is correct. It is 2 raised to m. But why? I'll just take an example. Yes. Your example sought to be correct, isn't it? 2 raised to m, and it is correct. But why it is correct? That is my question. Total number of binary relations which are possible on Cartesian product of two sets A cross B will be 2 raised to multiplication of the individual cardinality values. Nothing else. But how come? How can you prove this? You can prove this by taking very simple examples and cross-checking on your own. Okay, if I have to prove this, I will prove this. Let us say, let we are having set A equal to only one element is present, and let I am having, let us say I am having set B with element as P. And taking the example just for making it easy, otherwise we could have a lot many elements involved. So let us say A cross B, what it is, how many pairs do I have? I'm going to have first pair as 1 comma P. I will have second pair as 1 comma Q. These are the pairs which are present in A cross B. 1, 2 are 2. Okay, perfectly fine. Okay, how many relations can I have? R1. What is a relation? A binary relation is a subset of Cartesian product of A and B. So in R1, I could have 1 comma P. I could have 1 comma Q. Next, we could have R2. In R2, we could have only 1 comma P. This is allowed. Okay, subset could have exactly same elements as that of original set, or it may have fewer elements as that of original set. So I would have here 1 comma Q. Okay, so this one. And from the property of subsets, What will be the fourth relation? Fourth relation will be empty relation or void relation, because empty set is a subset of every other set. So in each and every case, I am observing that two pairs are involved in the binary relation. Okay. What is the cardinality of A cross B? Cardinality is 2. And using this formula, how many relations are possible? Maximum 2 raised to 2. This comes out to be 4. Why 2 in base? Because it is a binary relation. Everywhere you are forming pairs of two objects together. Is it clear? Why it is 2 raised to m into m? Okay, so for this case, number of possible binary relations are 2 raised to 2, coming out to be 4. Is it? Fine. Somebody may claim that why can we write like p comma 1? No, you cannot write p comma 1 because it is totally changing the type of association that has been established between the two objects a and b, like this. Okay. Okay, I hope this is clear. So let us move on towards what we have discussed so far. We have discussed about Cartesian product of two sets. This is pairing of A and B in this manner. Okay. And then we have observed the definition of n tuple. If you apply cardinality, it will be multiplication of individual cardinalities. Next to this, we have seen the examples. This is a new concept. Okay. You can represent the Cartesian product in terms of a diagram, a tree diagram. Likewise, you are observing that I have started from this root. Root is not having any value. We are having three different elements, 2, 3, 4, and here we are having element 4, 5 at each branch. So this 2 will be paired with 4, 2 will be paired with 5, 3 is paired with 4, 3 is paired with 5, 4 is paired with 4, 4 is paired with 5, and likewise. This is Cartesian product of two sets A and B. So what are the elements of A? Elements of A are 2, 3, 4, while elements of B are 4, 5. So you are having individual pairs. You could observe that A cross B is not equal to B cross A. If I take 4, 5 first and then I am pairing it with 2, 3, I will have altogether different pairs. So Cartesian product is not commutative. This can perhaps extended for larger sets. This is a pairing of A cross B cross C as well. So what is a relation? A binary relation. Any subsets of A cross B is called a binary relation from A to B. Okay. In a similar manner, if B is subset, if we have to define a binary relation on single set, we need to take Cartesian product of that set. Any subset of A cross A is called a binary relation on. For finite sets A and B with the individual cardinalities m and n respectively, there will be 2 raised to mn possible number of relations from A to B. This was the point which I discussed recently. Okay, last 2 to 3 minutes. Okay, all are there. I am observing that there are 57 in this meeting. Okay, moving further. So can you tell me quickly what is the solution of this example? Let A is 1, 2, 3, 4. Which ordered pairs are present in the relation R? A comma B such that A is less than B. Can you tell me quickly what are the pairs present here? Others can simply tell me what will be answer. A less than B. So we will have first pair as 1, 2. Second, I will have 2, 3. 1, 3 is also valid. I will have 1, 4, then 2, 3, 2, 4. So these are the only possible pairs for this. Okay, we are having 3, 4 as well. Now, two concepts known as domain and range. These are applicable for binary relations only. What do you mean by domain? Domain is set of all 4 elements. Okay. Okay. So what is domain? Domain is set of first elements in the Cartesian product. So that means whatever elements you are having on the left hand side of comma, those elements will be present in the domain, and whatever elements those are present on the right hand side of comma, those will be treated as range. So set of first elements in the Cartesian product are domain, set of second elements in the Cartesian product are range. So what is the domain for relation R? Domain is 1, 2 and 3, while the range is 2, 3 and 4. That you are observing. Domain set of all the leftmost elements before the comma. Range set of all elements after the comma. 2, 3, 4. Am I clear? Okay. Further to this, we are having several concepts like converse, finding the complement of a binary relation, and so on and so forth. Before stopping for today, I do have one exercise, small exercise for you, that you will be telling me the answer quickly. Okay, let R be a binary relation. Before going for binary relation, let me have 2, 3, 4, 5, 6. Okay. And we are defining R on set A such that A comma B such that Cartesian product of A minus B has to be 2. Quickly tell me what are the elements of R, what is the domain of R, and what is the range of R. That you have to tell me quickly. Then we will stop for today. If you understood. What are the elements of R? Not Cartesian, or it is absolute value of A minus B. That should be 2. That is given, not Cartesian. Okay. What are the pairs present in R? Yes. Mahesh, have you given the answer for this? Okay, 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. Okay. 1 is not present. No? I have not taken 1. I have taken elements from 2 to 6. So how you will have 1? Can I have 2, 4? Yes, 2, 4 is possible. Difference is minus 2, but it is accepted because of that absolute sign. Okay. Can I have next? 2, 4 is possible. Then I will have 3, 5. Yes, comfortable. Then I will have 4, 6. Yes. Then I will have 4, 2. Then I'm going to have 5, 3. Then I'm going to have 6, 4. Does it make a sense? Only these many pairs you will have in your answer. Remember that this 2, 4 is different from 4, 2. In 2, 4, value of A is 2, while value of B is 4. While in 4, 2, A is 4 and B is 2. Are you getting? Elements are 5. 4, 2, 5, 3, 6, 4. Those who are saying 4, 2, 5, 3, 6, 4, you must have 2, 4, 3, 5 and 4, 6 as well. Why? Because it is taking absolute. So there will not be any negative. If it was clearly mentioned only A minus B, you could have taken only those pairs like 4, 2, 5, 3 and 6, 4. You get it? So in this case, what will be domain? It is denoted using symbol D of R. D of R stands for domain of R. Set of all elements coming before comma in the relation. So I am observing 2 is coming, 3 is coming, 4 is coming, 5 is coming, as well as 6 is coming without repetition. Okay. And what will be in range? Denoted using symbol Rn of R, n in suffix. Rn of R. Range of R is elements coming after comma 4, 5, 6, 2, 3. So here we are observing that domain and range are exactly same and those are matching with the original set. Sometimes it may not happen. Is it fine? Is it fine? Domain and range both are 2, 3, 4, 5, 6. Is it fine? More on this in tomorrow's morning lecture. Before we conclude for today, let me mark your attendance quickly. If it is possible, you can turn on your mic and you can simply say present or absent. I have observed many discrepancies in the last attendance. Okay, many are joining and leaving the meeting. So you will be marked absent for sure if you are not present. Just a second. I know that it is almost 1:30. You do have other things as well. Quick. Abha, do we have Abha Singh present? Yes, I observed her. Okay, somewhere. Aditya Aghav. Yes, Abha, you can leave the meeting. Okay. Aditya Aghav. Aghav Aditya. Aghav Aditya is not there. Okay. Akanksha Shedage. Yes. Okay. Fine. Next. Aminabi. Okay. Fine. Babre Akshata. Babre Akshata. Do we have Akshata Babre? No. Okay. Moving further. Bagal Swapnil. Barate Ashish. Akshata Babri is present. Okay. Ashish Barate. Ashish. Do we have Ashish? No. Okay. Moving ahead. Bhoi Sunny. Yes. Good. Boite Ruturaj. Ruturaj Boite. Yes. Bhor Abhishek. Bhosle Anurag. Bhosle Anurag. Okay. Those who have given the attendance can leave. Okay. You should not wait for the others. This was only for